Assalamu alaikum. Welcome to Exchange Native. Here we have a good example to understand how activation energy can be extracted from a plot. But we don't know how to plot or which plot to use in order to get the activation energy. We should understand or extract this information from the mathematical relation between the speed and temperature and activation energy. How we can do that? If you remember, in the previous example, we solved a coefficient, or we can say speed rate of the reaction, but like as a function of temperature. Okay, so this reaction rate as a function of temperature is just exponential function of e to the power minus activation energy over RT. Okay, so here we have K and temperature. We have the speed and we have the temperature. Okay, we have the coefficients and we have the temperature values. But first of all, actually, just don't make a mistake in terms of units. So you should convert it to K, adding 273. Don't make a mistake in this point. And so when we plot, of course that we need to use Kelvin. But can we plot K as a function of time and we get activation energy directly from that? I don't think so. Because here activation energy is just like exponential rate. We need to leave this alone. So we will do something some logarithmic steps. Let's take logarithmic of both sides. So we will get this equation, right? ln k equals to this. So here you have ln k. So this k is given as like a variable, right? It's changing, and here it's changing, and the second thing that is changing temperature. So these are variables. So let's arrange them in terms of variables and constant values. So this t is variable, right? So let's separate them and use this multiplied by 1 over t, because t is a variable, so this is constant, so we can separate them. 1 over t you have in the right side and ln k in the left side. If you take derivative of this function, okay, in order to calculate the constant, if you remember, if you have y, y as a function of x, you have m times x, okay? So this m is your slope. So when you plot y as a function of x and you get the plot, how you get the plot, dy over dx is your m value, okay? So same idea we will use, but here your y value is ln k. So d ln k, okay, over, what is the x here? Instead of x you have 1 over t, okay? You are taking derivative of 1 over t. That means in the y-axis, when you plot the values, in the y-axis you will have ln k, okay? And in the x-axis you will have 1 over temperature. And you have something, you have a slope, okay? That slope, this slope will give you the minus activation energy over r, okay? Since r is a constant, you can get from slope activation energy value. So let's plot this in Excel, because Excel will be easy to work with. So, or we can also bring our relations. Okay. So we have, let's say, t and speed k values. Temperature values is, let's put now in terms of, in unit of Celsius, then we will convert. Okay. So we will have k values, or we can also say t as a unit of Kelvin. We will need to add just 273, okay? Then we have k. But we will need also L and K, right? And we also need 1 over temperature. Here we can say we will need 1 over temperature. 1 over temperature, which is equal to 1 over this value. And we have L and K, okay? So you can also get logarithmic function from Excel. Okay, so we have all values. Now we only need to plot. Here I have the Turkish version of Excel, but it doesn't matter. I think you know how to plot. So you come to Insert and just select a plot type. Then you add your anything, just is the name of the plot. You can say L and K versus 1 over T. Here it's x values, so my x, if you remember, will be 1 over T, and y values will be L and K. Okay, so as you see, actually, it's better to use Excel for this problem. When you get slope between two different points, as you see, the slope is like different. You will need a regression. You will need to fit a straight line or first order polynomial for this these data points because they have a varying slope, but you will use the best fitting straight line for this like this data set. But if you use like calculator and get slopes, you can get different values between all these points, and you should be sure you can do this, but like take the slope of them, maybe average them, or just use one of them, but note that like more accurate result can be like extracted from an Excel plot or something else. If you're in an exam, you cannot use this plot and get a like straight fit. It will take like, it will need numerical methods, and it's not required to do that. So what you can do, just plot by values, put the points, and just get lowest and highest points and take the difference between them and fit a line just between only 2 points, maximum and minimum. But here we have like computational tools. It is better to use it and get the like regression fit, first order polynomial, and also we can show let's see how we show the slope. Okay, we can show the equation so we can understand this slope from there. Okay, so we have a constant value and we have a slope here. Slope value is this one, okay? So let's copy this to our solution page. Now we can say that this slope value, okay, m is now calculated, and that's equal to minus EA over R. So that means EA, the minus signs will cancel each other, will be 5,412.3 multiplied by R. And actually this value is like unitless thing in Y, and you have like what you do is just D ln K over D 1 over T, right? So here you have unit of 1 over K, and here unitless. So you will get unit is Kelvin. Unit is Kelvin. Okay, so this is like, you can say this is Kelvin. Unit of the slope. And you have R, you can use the ideal gas constant. You must use it as the ideal gas constant, so kilojoule per mole. I mean, you can use different values. You can use this as joule per mole Kelvin, or multiply it by this and convert it to kilojoule per mole Kelvin. and kelvins will cancel each other, and you will end up with the unit that you want, which is kilojoule per mole. And this is the unit of activation energy. So it's approximately 45 kilojoule per mole. This is the activation energy, and this is the idea how we use plot and get the activation energy from the slope. But just please focus on the steps of the mathematical derivation of like how to decide which y value to get in the y-axis and which variable to use in the x-axis, and how we calculate the slope. We just worked through all these steps and proved that the slope of this plot will give us minus EA over R. Then from there we got the value of the activation energy. Thank you for watching.